at Harvard University. Professor Burt specializes in poetry, especially 20th and 21st centuries. She also studies science fiction, literature and geography, contemporary writing, comics and graphic novels, and literature alongside other arts. As a critic, scholar, and poet, Professor Burt's recent works include a collection of poems, Advice from the Lights, and the critical work, The Poem Is You, 60 Contemporary American Poems and How to Read Them. So, and just on the format, so our two panelists are going to speak. There will be a brief break, 3 to 5 minutes afterwards, and then we'll have the second panelist be introduced and speak, and then we'll have a general Q&A afterwards.
Does that mean I'm going first? Does that mean I'm going first? Okay.
Yes.
Okay. I guess that's what we're doing. Yeah. This is going to take a little under half an hour. I am going to argue, and is screen sharing a thing? Can you enable screen sharing for everybody? Because there are a couple moments where I'm going to want to share some things.
You can share your screen, Stephen.
Okay, great. I will share my screen when it's time. I am going to argue that identity, and I should also say if this were set up slightly differently and if it were live, we would be playing Betty by Taylor Swift right now. So if you're a Swiftie, just think about it. Imagine that it's sort of the first few chords. I'm going to argue that identity in identity politics, the identity of the persons we imagine inside lyric poems, and the identities of real persons are in one sense the same thing, and that if we acknowledge one, treat one as a real consequential thing, we need to acknowledge them all. We are now told, those of us in literary studies, and we've been told since the 70s, although recently with new scholarly force, that the poems we are used to labeling as lyric need not or do not portray interiorized persons, or that we should not imagine that they do. But the person we imagine as the speaker inside or projected by a lyric poem, who may or may not be the poet or be like the poet, is in some sense, and this is, I'm going to try to persuade you of this, as real and as self-identical as you or I, and our ontological status in the eyes and ears of others may be more contingent than we think. And that conclusion about identity has implications not just for poetry and poetics, but for science studies and for science fiction. Because if we deny poems the right to contain speakers, we are also denying robot rights and denying the possibility of general AI, of a conscious machine, and quite possibly denying the reality of the people here electronically today. So, identity means a lot of things by no means identical with one another. It is what William Empson called a complex word, and Raymond Williams a keyword. Philosophers give us the problem of names and identities. Famously, when is the morning star the evening star? And the problem of the continuity of personal identity. Am I the same girl I was when I was 12? And what if I wasn't a girl then? Can my grandmother be the same girl she was? And can she ever be my grandfather? And I'll get back to that. Social theorists and journalists, meanwhile, give us identity politics, social divisions and movements based on what a group of people seem to have in common, whatever defines them as a group. Deaf, capital D, identities. Queer and trans identities. Afro-diasporic identities. Armenian Americans and wheelchair-using Canadians have identities in this vernacular sense, but physicists, grandmothers, or shy people might not, even if being shy or being a chemist or physicist seems more fundamental to your identity than your wheelchair or your last name. Mike, I believe it is being recorded. I will return to that problem, which is really a question not about your identity, what makes you uniquely you, as a question about your similarity. Among all the things you have in common with other people, which ones are important? Now, those questions, what makes you you, what connects you to others, what defines how they see you, seem to be the province of fiction, realist fiction, which asks how events can change you, as well as science fiction, as in Derek Parfit and other philosophers' famous transporter experiment, which led him to claim that identity is not what matters. For Parfit, mental continuity of experience appears to be a better name for what we normally call identity, for whatever makes you feel as if you were the same person you were one day or 12 years ago. Parfit's experiment is being run and rerun in current X-Men comics, where mutants get routinely revived in one place whenever they die in another, in new bodies, in a process that almost everyone within the stories agrees to call resurrection. Except Nightcrawler. Different paper. That process and its fictional social context also support the philosopher Mario Schechtman's view that what matters requires shared contexts. We are so made, most of us, even Nightcrawler, as to seek confirmation that our experience makes sense, that it adds up to a story about a person. And when our stories lack external confirmation, we break down or feel that we failed or that something has failed us. Most of us require social support for our mental continuity of experience, for our stories, if not for our identities in any stricter sense, since we are always changing and thus not identical to, but only similar to, our previous selves. Thus, when Captain Kirk or Michael Burnham from Star Trek try to survive in the Mirrorverse, they must persuade their new evil shipmates that they are plausibly continuous with the people whom Evil Mirror Kirk and Evil Mirror Burnham were before. Identity works that way in fictional narratives, which track characters over time. Fiction is about what happens next, as Jonathan Culler, the literary critic, tells us. But lyric, Culler says, is about what happens now. We believe that about at least some lyric poems, that they take place in the now, even though lyric poems are sonic art forms. Like the songs from which they supposedly evolved, they take place over time, stretching out an instant into a few stanzas or a few minutes or 100 lines. Culler's polemical study theory of the lyric further suggests that the essence of lyric poems is not character or voice, but some other sonic effect called voicing, along with ritual and hyperbole and apostrophe and personification. Like most generalizations, this one works well if you pick your examples carefully. Yet it is hard for me to imagine Langston Hughes's poem Mother to Son, or Wordsworth's Westminster Bridge Sonnet, or George Herbert's Jordan poems with their explicit I, or Elizabeth Bishop's Song for the Rainy Season, which with its explicit and limited we, without imagining someone who could speak or say them. And I believe Chris Spade, who's in this call, has written about that at great length, and very well. We can distinguish lyric from spoken impersonation, as Culler does, through its resemblances to song. We might do just as well to distinguish it from song proper on the grounds that both give voice to imagined characters and emotions, but one relies on melody as well, and often on chordal accompaniment, while the other may use nothing but words. And Marissa Galvez, in fact, has found the origin of Western European lyric more or less in that distinction, tracking it chronologically through continental songbooks that turn into books of lyrics, plural, and then into what we call lyric alone. And Marissa, tell me if I got your book wrong. Did I get your book wrong? Okay, good. Is Mother to Son the same poem when I read it, when I speak it, when a voice more like Hughes' own speaks it, and when it is read in a promo for NBC's TV drama Bel Air? Bel Air is not the same thing as its comedic model, The Fresh Prince of Bel Air, and Ryan Adams' misconceived 1989 is not the same as Taylor Swift's magnificent 1989, though they have the same songs. But is Red, Taylor's version, the same as Red, the 2012 version? They sure sound similar. Physical copies of Red are the same as one another, but not the same, according to what philosophers call the distinction between type and token. Taylor's versions of her song Betty are all the same as your own acoustic coffeehouse version and as my hyperpop version, according to copyright law, which regards performances as token-like and sheet music as a guide to type. But do all the songs describe the same imaginary person? known as Betty? Do we imagine their singer each time as a version of Taylor or of her character James? Are they the same character? The Taylor verse on the internet sure thinks so. I'm not in a library. This is my office. Let's take a look. What if we translated and then recorded Taylor Swift songs into Spanish? Are they the same songs? What if we translated Lord's Solar Power, as she has done, into Te Reo Maori? What if we translate Sappho 31 into English, as a lot of people have done? That's the wrong clip. Hang on, here we go. Here we go. What if we translate Sappho 31 again and again over thousands of years? Is it the same poem? When is a poem the same as its translation? And when are translations the same as one another? If they are never the same and no two are identical, what's the best way to describe whatever they have in common with the original poem? Is there a sense, and I would argue that there is, in which Taylor Swift's song Betty, with its pivotal line, "Then I saw you dance, plus I saw you dance with him, plus I saw you dance with him," might be regarded as a free translation of Sappho 31? I would like to argue that there is, and that this sense, a sense in which the people or the characters we imagine behind or within the poems and the songs are, to quote Derek Parfit, what matters. This sense is not only fundamental to the way that lyric poetry works, if it depicts characters at one moment in time, but also fundamental to the way that we live when we're not reading literature or listening to music, the way that we live from day to day as social beings, and the way that we can, indeed should, regard any future instance of general, conscious, artificial intelligence. Put glibly, the I in a lyric poem, ancient or modern, is also the I in everyday conversation, and both are the same as the I in familiar cases for AI rights. Now, to see why, we should think in Sheckman's terms about the social recognition of character, about how we know there is a person speaking or imagine one, and about how recognition and imagination are in this sense inseparable from each other. Recognition, of course, has other senses too. The parliamentary sense in which a member of a debating body acquires the right to speak and the ability to be heard, and the strong sense familiar from the philosopher Emmanuel Levinas, in which an I sees a you as real yet irresolvably dissimilar. We participate in a poem by recognizing an imaginary speaker or imagining a recognized speaker, by treating the identity of that speaker as momentarily significant, as something real. I'll say that again. We participate in a poem by recognizing an imagined speaker or imagining a recognized speaker. And in doing so, we recognize what we as vernacular users of English have learned to call an identity. An identity here is what Empson called, in The Structure of Complex Words, a great book that people should read again, an A equals B statement. By using the term identity, we imply that a person can be a self, that continuity of character is at least a coherent concept, and that we can imagine an I behind a piece of artful speech, whether the speaker emerges from recently published quatrains or from Betty or from a lecture at a 19th century lyceum. It's no wonder then that poems that seem to allegorize art making or poetry making often turn out to allegorize the making of characters whom other characters recognize, or to allegorize their failure. That's what happened in both of George Herbert's Jordan poems, in which Herbert asks what it takes for a poem to make its implied author and its constructed speaker recognizable in the eyes of God. Jordan 2, the second Jordan poem, mostly recounts Herbert's failure to write the kind of poem he says he wants to read. And I'll read it to you. Marissa, if I go to 330 or 340, does that seem right? Because we started at 310? 340? Thumbs up or thumbs down? Okay. I often blotted what I had begun. This is the 17th century poet George Herbert. This was not quick enough, and that was dead. Nothing could seem too rich to clothe the sun, much less those joys, that is, divine joys, which trample on his head, which are above the sun. As flames do work and wind when they ascend, so I did weave myself into the sense. But while I bustled, I might hear a friend whisper, "How wide is all this long pretense?" There is in love a sweetness ready penned. Copy out only that and save expense. The true poem that reflects what Herbert wants, or what he wants to want, might sound much less individual, more like a copy, than the failed poems of rich but sublunary wit that only Herbert can write. To weave myself into the sense is to fail. To succeed is to give up one's identity and join the unison in a community of believers, except, of course, that we recognize this very sentiment, and especially its ending, as quintessentially Herbert's, if we're Herbert fans. Nobody else sounds like this. Herbert may come closer to or farther from his God, but he cannot stop being himself, and in the poems we take to typify him, from the Jordan poems to another poem called The Collar, he trusts that God may recognize him anyway. Now, those of you alert to changing lit-crit fashion may recognize that I'm not just defending a claim about lyric poems as ways to embody in words an imagined identity, a claim allied to Alan Grossman's claims and to Helen Wendler's and to Richard Streyer's and to some others. I'm not only disagreeing with Jonathan Culler, but I'm disagreeing more aggressively with a very influential and very smart writer called Virginia Jackson, who thinks that lyric poems in the modern senses of lyric, poems that ask us to imagine a speaking character whose words are like songs from the soul, that lyric poems in this sense are modern creations, artifacts of a process called lyricization that took place partly in the 20th century. Now, that claim cannot be disproven, because attempts at disproof can always be reinterpreted as denial or as ahistorical. Otherwise, we might find plenty of disproof not just in poems that 20th century critics loved, like Herbert's, but in poems 20th century critics mostly disdained. Once popular poems like E.B. Browning's Sonnet from the Portuguese, which don't make much sense unless we imagine a speaking person who is the same from line to line and sonnet to sonnet. And that person invokes a tradition of her own. Theocritus in Sonnet 1, the Portuguese love poet and epic poet Camões in her title, that's the Portuguese, and a figure of wine as love that goes back to antiquity, along with the figure of touch. It's a love poem. Thy touch upon the palm, and she's remembering touching her beloved's hand. The widest land doom takes to part us, leaves thy heart in mine, with pulses that beat double. What I do and what I dream include thee, as the wine must taste of its own grapes. Whatever the set of effects is, I don't think we can call it 20th century artifacts. We might find here an example for the critic William Waters' claim that lyric makes palpable poetry's claim on being read, in moments that evoke physical contact. We might call Browning's sonnet a better example of lyric and of the persons projected in lyric than much of the more elusive or evasive or fragmentary personification we find all over Emily Dickinson, who so often seems to escape her ideas of identity to be non-identical to herself, which is one reason why Dickinson has been so attractive for counterintuitive or deconstructive claims about how poetry works. Dickinson's poems are, as Waters also says, atypical examples of lyric in the same way that racing greyhounds, mastiffs, and baby chihuahuas are atypical examples of dogs. Browning's own spaniel, Flush, might make a better example. The spaniel she herself addresses in a very over-the-top poem as her loving fellow creature. As Gertrude Stein might have put it, and there's at least one Stein scholar on this call, she is herself because her little dog knows her. I know myself to be myself. Only when someone confirms my sense of myself, though that someone may be a dog or a person I know parasocially through Twitter or through a poem. Browning's sonnets and Herbert's Jordan poems and any other poems I want to call lyric are like real conversation and like literal songs, like Betty, in that they lend themselves to our imagining that there is a person behind them, a figure with an emotional life we can infer or guess at from what they say. They are sonically heightened, especially complex or compelling opportunities to do what we do anyway whenever we answer a letter or a text, inferring some personal identity behind those words. And note that we don't have to be right about who that person is. You can think she's E.B. Browning. I can think she's Sarah Morgan Bryan Piatt. Somebody else can think that she's Diana Prince or a dude. The point is that we have to imagine someone for the poem to work. And that kind of imagination is also what we do if and when we participate in Turing tests. The famous imitation games that Alan Turing, can I assume people on this call know who Alan Turing is? Is that safe? mid-century computer scientist, super admirable, did a lot of code breaking, also queer martyr. Please know who Alan Turing is. And one of the many things he does was propose a test by which we could figure out whether we should count a machine as conscious. And his idea was that you would have a human at one terminal and a machine at another, and a second human at another. And the first human would ask questions and do a kind of text-only dialogue with A and B and try to figure out which one was the human and which one was the machine. And if the machine passed as human, then it was conscious. And if the machine could never pass as human and the tester always got it right, who's the human and who's the machine, maybe the machine wasn't conscious. Less well known than the test itself is Turing's delightful response to imagined objectors, who suggest that a simulation of consciousness might never be the real thing, that you could have identical communications without real identity behind them. The only way, I've got it in front of you, the only way by which one could be sure a machine thinks is to be the machine and feel oneself thinking. That is the solipsist point of view. It may be the most logical, but it makes communication difficult. A is liable to believe A thinks, but B does not, while B believes B thinks, but A does not. Instead of arguing continually over this question, it is usual to have the polite convention that everyone thinks. In other words, the leap of faith by which we agree to regard a text as having consciousness behind it, and a poem as a way to imagine a person, is the same leap or agreement or stance by which I agree to imagine that you exist, and by which you agree to imagine that I do, if indeed you do. I might, of course, be imagining or ahistorically back-projecting you, and you might, as Paul Damon never got tired of reminding us, be dead by the time I hear your words. Again, I'm not making a claim about accuracy or validity in interpretation. I might recognize you as speaking to me or as projecting a person towards me from a poem while getting you deeply wrong in your own eyes, or in Marissa's eyes, or Jordan's, or Emily's, or Juliana's, or Chris's, or anyone's. The point is I recognize someone, I pretend or agree to hear someone in there, whether my pretense rests on deep conviction or the suspension of disbelief, or, as Turing says, and he's not quite kidding, on polite convention. On such conventions, whole societies and romances and friendships and kinds of literature rest. And those polite conventions might explain why, oh no, Jane's poem is missing. I really want to show you this segment of a poem by Janie, so I'm going to see whether I can project it here. Here we go. Can all of you see a poem beginning "How I Was Made"? No? Okay. Let me try to fix that. I knew there'd be some technology problem. I'm going to stop. I'm going to do a new screen share. Here we go. Anyway, these conventions help explain why AIs and robots and thinking machines are such a frequent focus for stories and poems about people who fear that we will not be seen as people. Poems like Janie's poem on being an android. And here's part of it. How I was made, equal parts mystery and on-off switches. Age 5, driving lessons, triathlon, med school, embroidery. Everyone says looks don't matter as long as you've got personality. My first crush was a Roomba I mistook for a person. Second crush, a person, but don't even go there. The lightning in my head means a brainstorm is coming. If I think hard enough about anything, my hair starts to curl. It's easy to predict the future when there's a timer in your neck. The instruction manual says my knee can be used as a utensil. Everyone admires my artificial skin, but nobody wants to touch it. It's Janie. My students tend to think that Ye's poem might gloss autism spectrum experience, or trans experience, other feelings that you're not quite like other humans, that your personhood isn't identical to theirs. But Ye's poem also speaks for its genre, for lyric poems as such. Lyric poems made things that seem to speak to us like persons, though Pache, William Waters, we can't touch them, are in this sense already like androids, or at least we pretend they are. For the critic So-Young Chu, robot rights represent the literalization of lyric figures. In scenarios where we treat robots like people, this is So-Young Chu, robots are placed within lyric structures of voice in which personification and apostrophe behave as forces that literally bestow humanity on non-human entities. Here we go. If Schechtman is right, the philosopher Mario Schechtman, who's about continuity of experience, personification and apostrophe, speaking of and speaking to, bestow humanity on human entities too. To treat a real person as not to be spoken to depersonify them, is to remove them to the not quite human, and by definition non-rights-bearing status of bare life. The way we treat the personae inside lyric poems while we're reading them is conversely the way we treat robots who plausibly claim to be human or conscious, and the way we treat humans too. In each case, the sense of identity requires the polite convention that everyone thinks. And Chu also writes, and maybe I'll end here, not only would a sentient humanoid robot, in its capacity as a made thing, constitute a freestanding object bestowing exterior shape on human sentience, but it would also constitute a living and sentient being in its own right. And such an object, I think, would emulate, or perhaps simply be, a lyric poem. And I'm going to stop there. Marissa, if that seems appropriate. If you want more, there is a kind of coda that takes about 5 minutes that is about the operation of personification and voice and the projection of personhood in the work of the novelist Richard Powers, who I think is kind of a Stanford person himself, right? Doesn't he have a Stanford connection now? But let's make that optional.
Yeah, we can always return back to it in the Q&A as a kind of footnote. But thanks for inviting us for the conversation. And so I guess
Thanks for inviting me. This is amazing. Thank you so much.
I want to talk about this right away, but according to our protocol, we're going to take a brief break, 3 minutes, and then we're going to come back and Jordan's going to introduce Emily. So we'll see you guys back here.
Did you say 3 minutes?
Yeah, 3 minutes.
Okay, see you in 3.
Okay.
Okay. Tell me when.
Go ahead.
Okay, hi everybody, welcome back. I've temporarily shifted so that my background will look more like Stephanie's to give myself a little bit of credibility. And it's my great pleasure to welcome Emily Rio, who I've known a long time, not as long as I've known Stephanie, which is about 40 years, but a long time. She's a colleague. She is an associate professor of math at Johns Hopkins University, and she has her PhD from the University of Chicago. And she studies category theory. I hope this is okay to say, Emily, a once niche, but now hot area of pure mathematics, and maybe even somewhat applied, as I think Emily will touch on in her talk, largely due to the efforts of a new wave of researchers in Emily's generation who are sort of bringing new life to the subject. And in particular, I'll point to Emily's book, Category Theory in Context, which, like Stephanie's book about poetry, has done a huge amount to kind of bring this subject into contact with a lot of people who may not think they're thinking about it, but actually are. And I'll just say, because the phrase category theory is probably, I mean, Emily's going to say a lot about it, but it may not be familiar to some of you. I mean, from the introduction to Emily's book, she describes it as, well, you could say she describes it as a mathematical theory of analogy, or as a theory of mathematical analogy, or maybe even a mathematical theory of mathematical analogy. I'm not sure what the right thing is to say is, but it's about analogy. And with that, I'm going to give it over to Emily.
Great, I appreciate the Eugenia Chang quote at the outset. She's also a great source for info about category theory. Wonderful, thanks so much for this invitation, and thanks in particular to Stephanie, who invited me to share this billing with her. So I'm going to share my screen, and I dropped a copy of the slides into the chat in case you want to have a look. Great. So it's really exciting for me to have an opportunity to talk about identity because this doesn't come up as often as it really probably should in mathematics or in a mathematics classroom. So famously, there's no I in mathematical writing. We have this convention of saying we will prove. we will discover, we will make the following definition in all of our formal papers, inviting the reader kind of along the journey of proving a theorem. Also, it's something that I've struggled with is it's kind of challenging to integrate questions of personal identity into a mathematics classroom. So if I want to come out to my students, for instance, I have to do something like shape my head. It doesn't come up quite as organically. There are some mathematicians who are doing really important work on inviting students to bring their entire selves into the mathematics classroom. One of them is here in the audience, Marissa Loving, so maybe she could talk a little bit about that afterwards. But since I think that most people here probably don't spend a lot of time in a mathematics classroom, I thought instead I would focus on some concepts that have been developed within various areas of mathematics, both category theory, as Jordan mentioned, and also homotopy type theory, that I think are maybe ripe for moving beyond mathematics. So what these concepts concern are what might be described as the art of giving the same name to different things. So this is a quote of Henri Poincaré, who's a topologist from the turn of the 20th century, who said that mathematics is the art of giving the same name to different things. So what he's referring to are, it's a common theorem would say that thing X, which appears completely unrelated to thing Y, are actually connected in some deep way. So that's sort of an exciting development within mathematics. So one thing that mathematicians are good at, I would venture, is reasoning very precisely about abstract concepts. And the way we do that is we convert words that are in common use in English or in other languages into technical mathematical terms. We give them a very precise meaning, and then that makes it sort of easier to think about and to communicate your meaning to another mathematician. So I'd be very curious about how the technical terms in mathematics interact with the complex words of Empson and the keywords of Williams that Stephanie mentioned at the first part of the talk. Maybe we could chat about that afterwards. Anyway, this talk will center on 4 technical terms within mathematics: equality, which is kind of the traditional notion of sameness within mathematics, isomorphism and equivalence, which are 2 notions of sameness that come from category theory, and then finally identity, which is a notion of sameness that comes from homotopy type theory. Though the term that would be most closely in parallel to the way that isomorphism and equivalence are used would be identification, which is something I'll say a little bit more about when we get there. Okay, so let's just begin. So equality is, again, the traditional notion of sameness within mathematics, and it is axiomatized by the following 2 principles. So these principles define the mathematical meaning of equals. So the first one is reflexivity. This is the solipsism principle that Turing mentioned and Stephanie mentioned, Turing mentioned. So it says that anything is equal to itself. Seems relatively uncontroversial. And then there's, I think, a decidedly non-solipsistic principle, which would be how, externally you could ask when 2 things are equal. It's called indiscernibility of identicals. This is associated with Leibniz. It says that 2 things are equal if and only if they have exactly the same properties. So what I've written here is a kind of more formal logical way to express that, but that's not so important. But anyway, the intuitive idea is 2 things are equal if and only if they have exactly the same properties. And this is quite a powerful principle because there are a lot of properties that something could have. Quantifying over properties is sort of a second order property. Okay, so let's illustrate what you can deduce about equality from the fact that 2 things are equal if and only if they have exactly the same properties. So there are some other properties of equality that are of interest. These are called symmetry and transitivity. So we're going to use the axiomatized properties of equality. That's reflexivity, the thing that anything is equal to itself, and indiscernibility of identicals. 2 things are equal if and only if they have exactly the same properties. And using this, we can prove, firstly, the symmetry of equality. So symmetry says that if X is equal to Y, then Y is equal to X. So let's prove this. So in the proof, we'll assume that X equals Y is true. We're trying to prove an if then, so you can assume the premise. So then X and Y must have exactly the same properties, because that's what is indiscernibility of identicals says. It says once we know 2 things are equal, they must have the same properties. But a property of X is that X is equal to X. That's the reflexivity property of X. So Y must have that property as well. Therefore, Y must also equal X. So that's how symmetry follows from reflexivity and indiscernibility of identicals. And similarly for transitivity, this is the property that if x is equal to y and y is equal to z, then x is equal to z. So let's assume, to prove this, let's assume again that x is equal to y. Then by indiscernibility of identicals, we know that x and y must have this exactly the same properties. But then in particular, if y has the property of being equal to z, then x must also have the property of being equal to z. So that's transitivity. Okay, so this is the traditional view of mathematical equality. But what it doesn't quite capture is some different things that deserve the same name. So the first image I have here is a painting that's actually in my office. This is by my cousin-in-law once removed, David Garcia. And what I love about it is he's drawn 20 circles that all look perfect to me. So in preparation for this talk, I drew a few circles. And of course, when you draw a circle, maybe your hand wobbles a little bit. If you try to draw two of them, they aren't quite the same size. They're not equal, certainly. Also, maybe one's over here and the other one's over there. But any mathematician would say, well, that's a circle and it's as good as any other circle. We don't have a circle that's sat in a vault somewhere in Paris that we compare all circles to. There's just the sense that even an imperfect circle could be considered as a circle as well. So these are different things that have the same name. A related example is this sort of famous joke that a mathematician would struggle to differentiate between a donut and a coffee cup. So here you might think of the donut and the coffee cup as made of some sort of unfired clay, and you could sort of put your thumb in and squash it around and transform the one shape into the other. So there's something similar about those, even though they're not equal. So I wanted to discuss a slightly more abstract example because this is more prototypical within mathematics. So a kind of thing that mathematicians are really interested in is the concept of symmetry. So you could think about symmetry of a particular object. So let's start by just looking at the figure on the left. So these are the symmetries of a twin mattress. So you have a twin mattress on a bed, and what a symmetry is it's a move that you could make to the mattress that returns it to the same position it was in originally. So if we start with our mattress on the bed, you could rotate it around in such a way that the top stays at the top, but the head and the foot interchange. Or you could flip your mattress, keeping the head on the head and the foot on the foot, but now it's upside down. So you can see the person on the mattress gets squashed. Or you could combine those moves. You could flip and rotate, moving the head to the foot and the top to the bottom. Or there's also something that's called the identity move, or sort of a trivial move where you don't actually move the mattress at all. You just sort of let the person on it have a little nap. So this collection of moves is what's called the group of symmetries of mathematics. Group is, again, one of these technical terms within mathematics, a group of symmetries of the mattress. And it's not just a collection of the 4 different moves. There's some additional structure, so you can compose these symmetries. You could first rotate your mattress and then flip it, and that gives you the flip rotate move. You could do a flip rotation and then flip it again, and that gives you the rotation move. So you could consider performing any finite number of these moves in sequence, and that's the symmetries of the mattress. Now let's consider a different object, a priori completely unrelated to a mattress, which is a t-shirt. And you can ask the same question about the symmetries of a t-shirt. How many different moves you could make that would at the end result in the person still sort of wearing a t-shirt. So one move you could do is you could pull it up around your neck, but leave it around your neck and then just rotate it around and then put it back down. That keeps the outside out, but switches the left and right arms. Or you could take the shirt off and flip it inside out and put it back on, but keep the left arm through the left and the right arm through the right. Or you could do the combination of those moves where you turn it inside out and also switch it around. And again, or you could leave it alone. There's still this kind of identity move. And once more, all of these moves can be composed. You could do one move in a sequence and then understand what that composite move is. And there's a profound sameness between these two abstract groups of symmetries, even though a mattress and a t-shirt have nothing to do with one another. In both cases, there are 4 different moves you can perform, and you can sort of match up the moves between the 2 different groups of symmetries in such a way that it respects the composition structure. So when you compose 2 of the mattress moves, it gives the same result as if you had composed 2 of the t-shirt moves. So that's really the sort of sameness that mathematicians would like to be able to reflect, but I can't say that these are equal. These are not equal as groups, but they are connected in another way, and this is the notion of isomorphism. So isomorphism or isomorphic really means that two things have the same shape, and mathematicians would argue that different things might deserve the same name because they have the same shape in some sense. So we would like a language that would allow us to describe what it means for things to have the same shape, no matter what kind of thing they are. So, one sort of thing mathematicians study are these groups of symmetries. Other things mathematicians study are the sort of spaces, the circles, or the coffee cup and the donut. Those are different sorts of things, but we want a language that in either context would allow us to identify objects that have the same shape. And that's what category theory is really good at. So what is a category? Barry Mazur has this really lovely metaphor. He says it frames a possible template for a mathematical theory. The theory should have nouns, which are the mathematical objects, and verbs, the transformations between them depicted as arrows. So category, again, it's a technical term within mathematics, though it's hopefully well chosen. So it's something that has some objects, some mathematical objects of some type, and then some arrows between them, each of which have a specified source and target. And then there's a requirement that you should be able to compose arrows. So if I have an arrow from A to B and an arrow from B to C, then there is a composite arrow that goes from A to C. And in addition, each object has something called a reflexivity arrow. This is not the usual name. And if you want to ask me why I've changed the name, we could talk about that afterwards. But each has a reflexivity arrow, and then there's some axioms about associativity and all that. So this notion of a category is very, very abstract, but it's kind of sufficiently structured that it allows us to give the following definition of what an isomorphism means. So inside a category, that's this thing that has these objects and these arrows and composition and reflexivity. We could say that two objects in a category, they have to be in the same category, otherwise this wouldn't make sense. They are isomorphic if there exist arrows. One would have to go from the one to the other. So F here goes from A to B, and then the other goes from the other to the one. So G goes from B to A. So that when I compose the arrows, I get the reflexivity arrow. So since F goes from A to B and G from B to A, there's a composite which goes from A to A. And I'm using the notion of equality here. So the traditional equality between arrows says that the requirement is that that composite G composed F is equal to the reflexivity arrow. And then also I require that F composed G is equal to the reflexivity arrow, but now on B, since F composed G is an arrow from B to B. So I'm using equality to define this more sophisticated concept of sameness called isomorphism. And there's a symbol for that. Mathematicians write the equal sign for equality, and we write this kind of equal sign with a tilde on top for isomorphism. So what's cool about this is that this does precisely capture the notion of sameness in all of the examples I mentioned above. So the group of mattress symmetries and the group of t-shirt symmetries are isomorphic as objects in the category of groups. The coffee cup and the solid donut are isomorphic or as objects in the category of topological spaces, for instance. Okay, so this all seems kind of abstract, I know. I want to take a little bit digression to sort of animate why mathematicians get excited about notions of isomorphism. And I want to digress by asking the question, why is 2 times 3 plus 4 equal to 2 times 3 plus 2 times 4? That's a question that, we teach elementary school students that this is true, but why is it true? I mean, what even are these numbers 2, 3, and 4? I mean, numbers somehow, feel familiar, but they're also just incredibly abstract. So, the way the mathematicians would really think about the number 2, for instance, is it's a representation of any set that has 2 elements. So it's an isomorphism class of sets of 2 elements. So here I've written the set A that has 2 elements, the star and the asterisk. So that is a set of 2 elements, and somehow it represents the number 2. But any other set with 2 elements would equally represent the number 2. So 2 is sort of a stand-in for any collection of 2 elements. So similarly, 3 is represented by the set B, which has 3 elements, sharp, flat, natural. C has 4 elements, and so represents the number 4. So if we're using these sets to represent the numbers 2, 3, and 4, there are operations on sets that can represent categorify is the term that's usually used, the operations of addition and multiplication. So one thing you can do with sets is form what's called their disjoint union, where you just sort of stick all the elements next to one another. So I've depicted the disjoint union of the set B with the set C. This has as elements the 7 elements that come either from B or from C. And then there's another operation on sets that's called the Cartesian product, which will take an element of the first set and an element of the second set and pair them up to form a single element. So if you've seen the Cartesian plane, that's an example of a Cartesian product. Here, if I take the Cartesian product of the 2-element set and the 3-element set, I get a 6-element set whose 6 elements are these pairs. You can see it, you can arrange them in a grid in a very natural way. So what 2 times 3 plus 4 means is you can take a 3-element set and a 4-element set, take the disjoint union, so sort of stick them together to get this 7-element set, and then do the Cartesian product with a 2-element set. And so that gives an 14-element set, which I've depicted on the left. Or I could take 2 times 3 plus 2 times 4. And what that means is I first take the Cartesian product of the 2 and 3-element set, and that's a 6-element set, and then take the Cartesian product of the 2 and 4-element set to get an 8-element set, then stick them together to get a 14-element set. So here at the bottom, I have these 2 sets. So what's interesting, and there's an isomorphism between them. So the isomorphism is somehow a reflection, a categorification of the equality. So what's interesting to me about this is, I mean, sure enough, we got 14 equals 14. That's all well and good, but there are 14 factorial different isomorphisms between the 2 sets that I've depicted. That's like 87 billion something. And yet I'd venture everybody here is thinking of the exact same one. So an isomorphism between sets is given by a function from the one set to the other and a function from that set to the one, so that the composites are these reflexivity functions, so that they're inverse functions. And I think all of us are probably thinking about the same isomorphism, even though it's 1 out of 87 billion. And I don't know, that seems interesting to me. Okay, I digress. So, right, so we've seen that the traditional notion of equality in mathematics can be categorified or enhanced to this notion of isomorphism, which is a bit more flexible, allows us to identify mathematical objects that sure feel like the same, even though they're not literally equal. The problem with that is that there are maybe even more mathematical objects that deserve to have the same name, even though they're sort of more different. So there's this thing in mathematics called the pair of pants, which I've depicted at the top center. And what it describes is a 2-dimensional space. So it's just kind of a surface that has a hole for the waistband and then 2 holes for the legs. And then there's something kind of interesting going on in the middle because, the one hole sort of continuously becomes 2 holes. It sort of splits up. So that's a space that's called the pair of pants. So I pictured a pair of pants on the left. And now you can imagine that your pair of pants is made out of wool and you stick it in the dryer really, really hot or the washer really hot. I don't know exactly how this happens. And it comes out and it looks like boy shorts. It's sort of shrunk up so much. It's somehow still the same pair of pants. But I want to imagine an even more radical operation where it shrinks so much that the bits that go kind of around the waist and around the back become not 2-dimensional, but 1-dimensional. So that's the thawing that I've depicted on the right, is we've shrunk our pants so much that we've lost the 2-dimensionality. Maybe there's a little 2-dimensional bit at the front for modesty, but the rest of it is not 1-dimensional. But somehow we still have the same fundamental topological structure in that there's the hole for the waist and the hole for the legs. And even though it's a radically different space, it's somehow the same. So that's the notion of sameness. Another example of the same type is depicted along the bottom. So you can imagine having a solid disk and then continuously shrinking the disk. So now it's a little bit smaller and a little bit smaller and a little bit smaller and a little bit smaller. So those spaces are the same in the sense we were considering before. They're isomorphic as spaces. But what's interesting is if I kind of take the limit of this process. So if I shrink all the way down, then eventually I'm left with just a single point. And a space that's comprised of a single point and a space that's comprised of a disk are pretty different. The disk has infinitely many points in it. The single point has just one. But somehow there's a notion of the sameness, which you can see by this movie where you're shrinking these spaces down. Or you could imagine expanding in the other direction. So I've drawn a finite kind of bounded disk here. But you could, if you continue on forever, you eventually have the infinite plane. And that arguably is the same as the point in the sense of sameness that I'm alluding to here. And what's so wonderful about this example is it's insensitive to dimensions. So imagine now that the pictures that I've drawn are not two-dimensional disks, but three-dimensional solid balls. So equally, a three-dimensional solid ball can shrink to a similar one and shrink to a similar one and shrink all the way down to the point. And by some transitivity of sameness, then the three-dimensional solid ball is the same as the point, is the same as the two-dimensional disk. And then there's nothing special about dimensions 2 and 3. This works in all dimensions as well. So what I'm describing are the family of contractible spaces for those who are familiar with that language. So another kind of example, which is a bit more sophisticated, but also quite prototypical. So now that we've defined a category, we can think of it as a mathematical object in and of itself. So an example of a category that I was alluding to in the discussion of arithmetic is the category of finite sets and their symmetries. So we can form a category whose objects are all finite sets and then all sort of functions between them that are invertible. So those are all isomorphisms between these finite sets. So this category is just indescribably large. So if you take any three things in the world and group them together, you have a 3-element set, and that is one object in this category. So you pick 3 different things, you have a new 3-element set. This is kind of inconceivably large. In fact, it's so large that its collection of objects is too big to be a set. Really, really, really big category, but somehow it's like super redundant because any 3-element set is as good as any other. So there's a related category where in place of all of the different 3-element sets, I'm just going to use the single object, which I'll call the number 3. So this new category has as objects, the number 0, 1, 2, 3, 4, all of the natural numbers. And we need to keep the data of the arrows. So the number 3 comes with 6 permutations of 3 elements as its group of symmetries. And this somehow contains the same information as this indescribably large category of finite sets and symmetries, even though it's much more efficiently packaged. There's a similar example that I love, which explains why there are 2 different ways to teach linear algebra, which is one of the kind of core mathematics topics at the college level. There's a more concrete approach to linear algebra using matrices and a more abstract approach to linear algebra using linear transformations in vector spaces. And on the surface, those courses seem very, very different, but somehow we're conveying the same information. So the theory can be developed from either perspective. So none of these types of things that I would argue deserve the same name are isomorphic, but we can develop language to explain how they're the same, and this is the notion of equivalence. So equivalence means, I think this comes from Latin, it means sort of equal worth or kind of equal value. So it's a perspective on equivalence. I guess that's the perspective I was taking in the linear algebra example, that it's sort of equal value in these 2 different categories. And in order to define what it means for 2 objects to be equivalent, the language of an ordinary category is not sufficient. But if I add an extra dimension, if I move up into a 2-dimensional category, I can get the definition. So a 2 category is like an ordinary category. That was something that had objects and arrows, but now I'm going to call them 1-dimensional arrows because on top of that, I'm adding these 2-dimensional arrows. So in a 2 category, I have my objects, my arrows, which go between objects, and then the 2-dimensional arrows, which go between parallel 1-dimensional arrows. So to give a full definition, I would have to describe how everything can be composed, which I'm not doing here, but you might imagine sort of geometrically ways that this sort of data can be composed, and that's probably about right. So within a 2 category, I can say what it means for a pair of objects, A and B, to be equivalent. This is a even more refined notion of sameness. And what it is, it starts out like the definition of isomorphism. It means that there must exist 1 arrows, one that points from the one to the other, and the other that points from the other to 1. So F from A to B, G from B to A. But then I ask for 2-dimensional arrows that compare the composites, that's G composed F and F composed G, to the reflexivity arrows. So alpha and beta are 2-dimensional arrows. And then there's a requirement that this alpha and beta are isomorphisms. And I mean isomorphism in the sense that we defined previously. So like we used equality to define isomorphism, I'm using isomorphism to define equivalence, which is a sort of 1 level up notion of sameness. And there's a symbol for that, which is like the symbol for isomorphism, but I drop one of the bars at the bottom. So all of the examples that I mentioned on the previous slides are not isomorphic as mathematical objects, but they are equivalent when considered as something that lives in an appropriate two-dimensional category. So this is kind of what category theory has to say about sameness. There are some problems, however. So the first is that this doesn't stop here. So if once you buy that two categories are themselves mathematical objects, you can ask, when are two categories the same? And the most flexible notion of sameness, kind of the best notion of sameness, isn't equivalence in the sense we've just defined, but it's a kind of categorified notion of equivalence that I'd have to define using a three-dimensional category. But now that I have three-dimensional categories, I could ask when they're the same, and there's a notion of equivalence, but it's defined using a four-dimensional category, and this continues all the way up. So that's a little scary. I don't know, something else that feels a little unsatisfying is that this category theory and higher category theory no longer provide a single meaning of when one thing is the same as any other thing. You know, we started with just a unified concept of equality that could apply to mathematical objects of any type. And now we're in a setting where to know which notion of sameness to use, we need to know kind of how complicated our object is. If it lives in a one category, then its isomorphism is probably fine. If it lives in a two category, then equivalence is probably fine. But you know, there's maybe some judgment involved, there's some experience involved. In practice, mathematicians do tend to agree on which notion of sameness is appropriate, but I mean, it's because we all spend a lot of time talking to each other and are kind of on the same page. There's another issue, which is that indiscernibility of identicals. This is the thing that things are the same if and only if they have the same properties, doesn't really hold anymore. So when objects are isomorphic or equivalent, but not actually equal. So as an example of that, we had this category, which was comprised of all finite sets and isomorphisms between them. And that is equivalent to the category that has just the natural numbers as objects and then the symmetries of the natural numbers. So the natural number category has, I can tell you exactly how many objects it has. It has countably infinitely many objects. I said infinity, so maybe that sounds like a lot, but this is the smallest kind of infinity. So, you know, mathematicians are pretty happy with countable infinity. Whereas this other category, you know, has even more than uncountably infinitely many objects, sort of too many objects to form a set. So that's a different property. However, those two things are the same in the sense of being equivalent. So that's also a little unsatisfying. And this is where the final notion of sameness comes in, called identity. Okay, so identity or really what I'm going to talk about are something called identity types, which come from type theory, which is another formal system for mathematics. It's a formal system for developing mathematics, making mathematical statements, proving mathematical theorems. So in type theory, there are two primitive notions. The mathematical sentences, these are the statements that are grammatically correct and you might try to prove, take the form of types, which I'll write with capital letters ABC. And then the other primitive is of a term in a type. And this provides a proof of the encoded statement. So a type is a mathematical sentence that may or may not be true, but at least is sensible. And a term in that is then a proof of the encoded statement. So what I've written here are Martin Löff's rules for identity types. So these define the notion of identity in type theory. And below, I've also written kind of informal ways to thinking about them. So the first rule says that if I have any type A and any terms X and Y in that type, there is a type X equals Y A. So it's written in red. That means it's a type, which is a little strange to think about. But remember, types are the meaningful mathematical sentences. So I think of this as like a no-nonsense principle. It says it's meaningful to identify or to ask whether things can be identified if they have the same type. So if X and Y have the same type, it makes sense to ask the question, does X equal Y? That's what it means to form this type. All right, so the second rule says that if I have any type A and any term X, then there is a term called the reflexivity term in the type X equals X. So remember, terms and types are proofs of the statement so encoded. So what this axiom is saying is that it is true that X is equal to X, or anything is identifiable with itself. So that's reflexivity coming back. And then the final rule is a bit complicated. What it says is that for any type P, and this type might depend on an X and a Y and a P, then if there is a term that proves that PXX RefLX is true, so this is a term sort of proving whatever property in the case of an X and its reflexivity proof, then there is a term in general proving this property for any X and Y and proof that X is equal to Y. Okay, so that's hard to get your head around, but what it's encoding is this indiscernibility of identicals. So the type P, the type family P, can be thought of as a property involving an X and a Y and a proof that they're the same. And what this is saying is once I have that proof P that X is equal to Y, then if I know this property of X, I could conclude this property of Y as well. So this is indiscernibility of identicals again. Okay, so Martin Liff wrote these rules for the identity types in the early 1970s. What makes type theory into homotopy type theory, as was mentioned in the abstract for the talk, is something called the univalence axiom, which was introduced by Vladimir Voevodsky in, I don't know, 10, 15 years ago. So what the univalence axiom does is it relates the identity types in the universe of all types to equivalences between types. And the notion of equivalence here is defined very similarly to the notion we just discussed. So the slogan for this univalence axiom is that identity is equivalent to equivalence. What that means is we can form the type, the identity type in the universe between two types A and B. So we can form the type of identifications between types A and B. And the univalence axiom is asserting, asserting that that type is equivalent to this type of equivalences between A and B. So the name univalence is a little bit funny. I included this long quote from Voevodsky that explained sort of where it came from. He mentions that in this famous book in algebraic topology in Russian, the faithful functor, which is a concept in category theory, is translated as univalent functor. So in his mind, univalence is associated with this idea of faithful. And his point is, indeed, these foundations seem to be faithful to the way in which I think about mathematical objects in my head. And that's really the main advantage, I think, of this new formal system. So as a consequence of this univalence axiom, we can revisit all of the things that we've discussed that deserve the same name. So we have our badly drawn circles, we have the coffee mug and the donut, we have the pair of pants and the thong, the contractible spaces, the balls of any dimension and the single point. We have the numbers 2 times 3 plus 4 and 2 times 3 plus 2 times 4. We have the mattress symmetries and the t-shirt symmetries, the categories of finite sets and the natural numbers, abstract and concrete linear algebra. All of these things can be understood as terms belonging to a common type. So the numbers are the terms of the type of natural numbers, for instance. The symmetries are terms in the type of groups, for instance. And as a consequence of the univalence axiom, so each of these types of objects has its own identity type, has its own meaning of when one thing is the same as some other thing. And identifications, so proofs of identity, recover exactly the notions of sameness that were previously introduced. So that's the real advantage here, is these identity types with their kind of funny rules plus the univalence axiom means that a term of an identity type, an identification, a proof of identity, is going to specialize in all of these different mathematical contexts to the things that mathematicians would hope that it is. That's what Voevodsky meant by saying this is sort of faithful to the way he thinks about mathematical objects. Okay, so let me conclude. So we've toured different mathematical concepts of sameness, from equality to isomorphism to equivalence to identification. So while I'd argue that the traditional notion of equality is a little too narrow, its defining principles, that's this reflexivity and indiscernibility of identicals, are worth preserving. And the categorical notions of isomorphism and equivalence, these are things that mathematicians will use every day in their writing. These identify objects that have the same shape or have equal work, but there's something a little bit delicate about them in that they require increasingly higher dimensional data as the objects we're trying to identify become more complex. The type theoretic concept of identification is then specified by these rules that demand sort of no nonsense, that it's only meaningful to identify objects of the same type, reflexivity, that everything is identified with itself, and indiscernibility of identicals. Two things are identifiable if and only if they have exactly the same properties, In the presence of the univalence axiom, these identifications then specialize to the correct notions of sameness for objects of each type. That's it. Thanks so much.
Thank you. That was so cool. And I'm gonna have to go back through some of those slides to be sure I got all of it. Like, I'm having that experience that one gets when one is able to follow most of something and finds it all fascinating. And
well, I blame whoever wrote the abstract for the series, because all of these ideas were there. I was just doing my duty of trying to explain why category theory and homotopy type theory were mentioned in a call about discussing theories of identity. So
maybe I can open up the discussion and try to bring these two papers together, and also kind of that we have some interesting questions in Q&A, so I'm going to gesture towards them. And so to bring the two papers together, and I agree with Steph, it's like, I mean, my mind's like blowing up. Yeah, it's so great. I think it's so interesting. I'm wondering if we can use these mathematical concepts or notions, the word notion has been brought up in the chat, to talk about the way Steph is talking about identity in lyric poems. And I'm particularly interested in this idea that lyric is about a moment, like what happens now, to bring up that color phrase and then, so at what point can lyric enact isomorphism, sameness? You know, in the beginning of your talk, Steph, you talked about like what are the how can events change you? How can what changes in a lyric poem and what doesn't? When is there that variability or isomorphism, or maybe to just apply these concepts that Emily talked about? When can lyric do that? If it's generally, you know, we have these frameworks of like temporality, sound in poem. And so I'm just wondering, you know, with the examples, Emily, that it was so helpful for me to the visualizations of like, you know, the pants to the thong kind of idea, like, you know, like in lyric, we have sound, we have, I'm thinking of the sestina where you have the six stanzas and you know, these rhymes that kind of duplicate and change within a poem. And, you know, someone like Patience Agbavi, who I'm sure Steph knows about too, has been able to use that form to kind of play with identity from like in a kind of gender, transgender kind of discourse too. And like, but it's moved, she does it through the form of the sestina and the changing isomorphic rhyme scheme, metrical rhyme scheme. So anyway, those are just some preliminary thoughts. And I don't know, Jordan also wants to kind of respond to, and then maybe we can both bring up the questions in the chat.
Sure, and I too am kind of, you know, thrilling to the resonances between the two talks. Maybe something, I think for me, what's so striking is the way that as Emily said, mathematicians use these words, but the way we use them is like slightly aslant from the way that they're used in common language and the way that they're used in literary study. And I think there's sort of like an interesting ringing tension between the two usages, where hopefully there's sort of something to be learned by the way they pull at each other. There's one, actually, Pelly Greetzer has a question in the chat that I think very much speaks to that, which I think is very cool. Maybe another thing I'll point to is the way that Emily talked about calling things the same because they're connected, which to people like us is very natural. But to people like Stephanie and maybe people who don't speak this language, it's a little bit more common to say, as Stephanie said, the things we might call things the same when they have something in common. And those two things feel different, right? To say two things have something in common and to say they're connected. I think in some sense, right, in the end, Emily, we would say that those notions end up having a lot of common with each other, but in plain language they don't. And so it's worth maybe it's worth pointing to that as a linguistic difference in usage. Like, does it seem weird to you, Stephanie, to say like, oh, these two things are connected, therefore it makes sense to call them the same? Like, to us, it seems normal, but I could see that it might not seem so normal outside our community.
So I think of identity in discussions of lyric and voice and personhood as really being whether things count as the same. is the persona behind E.B. Browning's first sonnet the same as the one behind her sixth sonnet? Are they the same person? And it turns out that one of the properties of persons and personhood is that the best way to answer questions about whether they're the same is to ask questions about continuity. But the question you start with is, are these substitutable? Are they the same? People are weird, and this is only a property of literary studies in as much as literary studies is a humanist discipline. People are weird because if you ask about identity, you end up talking about continuity. But the initial questions are still about identity. And anyone in this room who's had to answer students' questions about whether the speaker in the poem is the same as the author, or whether the author is the same as herself, or Yeats talks about this, and Eliot, as he tends to do, citing Yeats, because Yeats never gets the kind of credit he deserves. He really doesn't. But Yeats talks about how the bundle of accidents who sits down to breakfast is not the same as the person who writes the poem. That's a question about substitutability. It's not or not initially about continuity.
So what Stephanie said.
Can I speak to I want to answer Paul Glendenning's question later, but I want to listen to Emily a lot more than I wanted to listen to myself.
Well, just real quick, what you're saying about continuity really resonates with the point of view on identity taken in homotopy type theory. So this last concept we discussed. So there's a sort of visual metaphor for types and terms that I didn't have time to introduce, where a type is like some abstract topological space. So some sort of cloud somewhere, and the terms are then the points in that space. And so you could ask, when is it that two terms are identifiable? So when do you have an identification between two terms? And the answer is exactly when there is a path that starts at the one and moving continuously through the space goes to the other. So the question of, is are X and Y the same? Is there an identification between them? Is exactly, or how you would prove that, a witness for that would be constructing a continuous path that starts at X and moves through time to get you to Y. So it's exactly the same perspective.
Do we have other questions?
Sorry, just one other, you mentioned substitutability as kind of another point of view on identity. Yeah. That's also reflected in homotopy type theory. So, and this is kind of why homotopy type theory is so powerful as a formal system. So a thing that is
Sorry, go on.
Proven in homotopy type theory, it's this indiscernibility of identicals property. Once you've constructed one of these continuous paths that takes you from X to Y, then what you're allowed to do is any further mathematical development that uses X, you could substitute in the Y and sort of transport all your information along that path.
Indiscernibility of identicals is the general case of substitutability. And things like literary no, it's not?
Sure, I think so, yeah.
Okay, yeah. Things like literary translation are special cases of substitutability. Depending on what you're trying to do with this text, you can substitute versions of Sappho 31 for other versions of Sappho 31. Or in the same language or in other languages, or the original for any of its translations, but they're not. They're only identical in certain contexts.
Mm-hmm. Maybe I can jump in there and try to fold in some of the Q&As that relate to this topic of substitutability. So I'm going to combine Gareth and Pelly's question. So Gareth had a question for you, Stephanie, about the idea, identity, and the concept of the self, but there's a more mathematician, they talk about a more nebulous notion, the idea of the a nebulous concept of notion. So could you speak to that, notion versus identity in terms of a concept of the self, and then also in terms of substitutability? Pelly asks, The identities Stephanie talks about are the identities of unity, identities of moments belonging to a process or parts belonging to a whole. And the identities Emily talks about are identities of substitutability, identities of things we can in a certain context place with one another without the replacement making a difference. What might we say from a math viewpoint, from literature viewpoint, about the relationship between these two kinds of identities?
I thought I thought we sort of already hit that.
Did we already get that? And
I
we're
think
elaborating on that.
I did a little bit think you were speaking to Pelly's question, whether or not you saw it in the chat, and the first thing that you said about substitutability. I didn't know if you were looking at Pelly's question in the, or if you just intuited what it would be.
I was looking at Pelly's question.
Oh, good. Okay.
Anybody want to interpret Hegel? I just want Franklin to interpret Hegel for me. I will. The only thing I'm going to say about Hegel here is that people who try to theorize lyric have developed a habit of deferring to Hegel in a way that I don't know is useful or defensible in terms of English language practice. But yeah, I don't. I can't. I can't answer Franklin's question if Franklin can't answer it.
I think it's cool that we have like a rock star of poetry criticism and a rock star of math talking, and then like a literal actual rock star has appeared in the chat to ask a question.
But are we allowed to call? I mean, this raises questions about the category of rock music.
I think of Franklin is not identifiable as such.
I think of Franklin as a star, but only some of his music is rock music.
Well, can I let me sort of de-Hegelize Franklin's question a little bit and put it to you, Stephanie, because another difference I see in the two viewpoints is that I think for people who do category theory, we talk about morphisms from A to B, morphisms between things, from one thing to another, to say whether we can call them the same. But it's very important, of course, to think about what we would call automorphisms, ways of identifying a thing with itself. And in the usual mathematical parlance, the identity is one such thing. So Emily changed that word to reflexive, to the reflexivity, and maybe she'll explain to us why. But if your talk, Stephanie, was very concerned with conversation, right? A conversation is a thing where the polite convention is that there's something at each end. That thing might be a person, or it might be a polite agreement to infer a person behind each end of the conversation. But just as the arrows in Emily's talk sort of had two ends, right? There's one thing at one end and one thing at the other end. But of course, in category theory, it's very important to think about arrows that go from a thing to itself, the identity being one such. And I noticed that conspicuously absent from your talk, Stephanie, was conversations with oneself. And I wonder how that fits in. Like, can you be, for instance, when you politely agree to the polite convention that you yourself are a person, like, could you be wrong about that? Like, could you be wrong in that internal conversation about what person you are?
Well, that goes in three different directions, right? One is the notion, which you find in some versions, not all of Buddhism, that the category person or self is not terribly useful or coherent, and we need to outgrow it or learn to think without it. And I don't buy that, but in its sort of Buddhist version, I have some. I feel warmly toward it. I don't want to talk you out of that if that's important to you. So you can say, well, there's not really a person there. You can also say that the actions others attribute to you, and the things that your body ends up doing, and the things that your language producing faculties ends up doing that have consequences for others, appear to be the result of a collaboration among internally non-identical parts of you that are absolutely discernible, and that can't be mistaken for one another. That happens when writers and artists experience solitude as a dialogue with oneself, Hannah Arendt writes about that beautifully in her last book. It also happens if you know anyone who sees themselves as a collection of alters or as a plural, or who speaks of themselves as we. I've known some people like that. And if you want to live like that and you get some help, you can. So it is possible to see yourself either as a collection of dissimilar entities, each of which has agency, or to try to throw out the notion of agency entirely, and to say there's really nothing there. I don't know how to throw out the notion of agency, but I know people who claim to, and that's something you can do coherently in a Buddhist tradition. It's something you can do, I think, incoherently. I don't think it works in certain kinds of continental Marxism, about which I'm also going to defer to Franklin. But yeah, you can be dissimilar to yourself. There's also the statement, which gets us right into sort of kinds of queer identifications. I was wrong about what I was. I'm not the person I thought I was. People say that all the time. And whether that is a statement about identity in the vernacular sense depends on how wrong you were and what you were wrong about. You can be wrong in thinking that you're good at basketball, or in the case of people in my household, at Smash Bros, once you play people who are much better at Smash Bros. And that may or may not speak to how you define yourself and whether you seem to yourself to be the person you were before. It might. Or you can be, as the Double Clicks say in one of their greatest songs, wrong about gender, which more commonly speaks to sort of who you are. It's not necessarily delusional. The word delusional just popped up in the chat. The word delusional it brings with it a medical context that I don't think we need here. You can just be wrong. And we're wrong about ourselves all the time, but only sometimes does that wrongness speak to every aspect of the actions that we take, or to who it is that we think takes the action. And I have windows on top of other windows. I'm going to try to...
Maybe I'll just jump in real quick. So I don't know anything about Hegel, so this may or may not be addressing that. But part of what I indicated in the title of the talk on the art of giving the same name to different things is that I think mathematicians really do prefer to have an expansive notion of sameness rather than a restrictive notion of sameness. So I can't imagine redefining sameness in a way that would make you different, sort of kill reflexivity, would mean that A is not identifiable with A. But I think the interesting moves are happening in the other direction, sort of how expansive this notion of sameness could be. So Jordan brought up the concept of an automorphism, which is a sort of way that something can be the same as itself. And that's a very rich, very, very deep subject within mathematics, because there are, in many examples, more than one ways that something could be the same as itself. There's the sort of reflexivity way, which is the kind of trivial way. But then there are, rich ones that reveal something deep about the structure of the thing that is being understood from this kind of external perspective. But what I would argue, I guess, as a category theorist, is that there's really no distinction between automorphisms and isomorphisms. So auto means it's a sameness between A and A. Iso means it's a sameness between A and B. So from the perspective of category theory, those notions are equivalent. I don't know, I guess I think that's sort of interesting. Once A and B have any isomorphism between them, it's no longer meaningful in a sense. I mean, this is kind of a new idea within mathematics that's being developed, but it's sort of no longer meaningful to distinguish between them.
Should I speak to Alex's comment? Alex Sherman's comment? Hi, Alex Sherman.
Can other people see those comments, or it's a great comment, but I just don't know whether, Marisa, do you know whether the audience can see those, or can only we see them? Because if they can't be seen, we should read it out.
Can I just, some people have auditory issues. I'm going to stick it in the chat. Hang on.
I'm gonna do. Well, I can do that.
Alex
I
Sherman,
think.
can I just stick it in the chat?
I did it. Oh,
I did it too. Are they identical? Have we just stuck them both in there?
oh no. Who is speaking?
So, okay.
We're covering Taylor Swift and Alex Sherman in the same panel.
I'll have to change my homeroom. So lyric imagines a person speaking. How specific we can be about that person varies massively from poem to poem. Helen Vendler would say that if it gets too specific, it stops being lyric. And I disagree, but I think I see why she would say that. Jonathan Collar appears to say that if it gets at all specific, it's not lyric because it's not really a character, and I don't think that's an accurate description of half the poems we call lyric. The person speaking in most of Shakespeare's sonnets is someone who is a fluent user of Elizabethan England, who is easily made jealous and has extremely variable self-esteem, and probably takes he/him pronouns. We can discern various things about that person, and we can move towards, or we can narrow down or expand the universe of possible people who could be speaking something, or the set of characteristics we know that imagined speaker to have, depending on what's in the poem. It's never going to be literally anyone, because only some people have that kind of temperament, and only some people, it's trivially true that only some people have that kind of language. But a poem that is full of anger is not going to be spoken by someone whose emotional range doesn't go there, for example. I think that the universe of potential speakers or imaginable speakers, or sort of dimensions on which you could place possible speakers for a poem, the size of that universe varies immensely from poem to poem. And the poems we are used to characterizing as dramatic monologues, some of which honestly function as lyric. I don't think it's coherent to define lyric in a way that programmatically excludes them. The poems we are used to calling dramatic monologues that have aspects of lyric, things like Tennyson's Ulysses or Browning's Andrea del Sarto, those are poems where the universe of potential speakers is very, very small. But they still function lyrically in that they give you a deeply interiorized feelings articulated in song-like language, or in orally intricate language of a person at a time. And if they're Victorianists in the chat, they're probably going to yell at me about how dramatic monologue is the opposite of lyric. And I think they're wrong. Marissa, are you okay? I know you're not a Victorianist. Are you uncomfortable with that claim?
No, can you say that again? Because I was just getting to what I was going to respond to that last thing. Could you elaborate on that last point? Because then I want to respond to it.
Okay. For the people from other disciplines in the chat, it is conventional to say that there is a kind of poem called dramatic monologue that is invented by Victorian writers, in which you have a person speaking to imagined live listeners, and that person is definitely absolutely not the poet, and they might have a name or be a historical or fictional character. And oh boy, are those poems different from lyric poems.
Right.
And I think that's wrong. I think that the most useful way to talk about lyric as a genre, as I've said, is it's a relatively short poem that is orally intricate and therefore in some sense song-like, that reflects the feelings of an imaginable character at a given moment in time. And sometimes that character really could be anyone. Sometimes that character could be anyone who's deeply Christian, or anyone who's really angry, or anyone who's consumed by lust, or anyone who's just been broken up with. And sometimes that character is an older gentleman whose marriage has just ended, or an orphaned small child in a cold climate. And sometimes that character is Ulysses. And I don't think My Last Duchess, I don't I don't think the category of lyric is very useful for talking about Browning's poem My Last Duchess, but I think it is unavoidable in talking about my favorite Browning poem, which is Andrea del Sarto. My Last Duchess is a poem spoken. My Last Duchess is a villain monologue, if we know what villain monologues are. And we figure out what's going on with the villain monologue while he monologues. And by the end, we know exactly what his evil plan is. It's great, but it doesn't work as lyric. Andrea del Sarto is this poem spoken by an extremely sad Italian Renaissance painter, in which we gradually learn, as he talks to himself and as he talks to his wife, who is not very well suited to him and who isn't listening, just why he's sad and what makes him sad and what kind of sad he is and what that has to do with his art. And I don't know that we need to bridge lyric and dramatic monologue. I think of them as overlapping. In almost the same way that like character song or story song and country music, or boast and hip hop are overlapping categories, right? Yeah, I think they overlap. Tom of Bedlam's song is absolutely something that fits the criteria we usually use for dramatic monologue and fits the criteria that we usually use for lyric, and also belongs to much more specific categories that exist in multiple times and periods, notably mad song and begging song, and visionary poem.
Well, one thing I always when I responded to this is because it's like the one thing so just to go like to Emily's point is A and B, like about is A is going to be. So let me give me an example from as a medievalist. So you take a lyric that was mainly a musical phenomenon in the 12th century by the troubadours. Is that A the same as that lyric in a songbook later on in the 14th century that's in a book that might be associated? I mean, what is the identity there? Like, you know what I mean? Like I'm not saying that A and B cannot be isomorphic, like they can be the same, but the fact is that they might be understood differently. I know you don't want to go into interpretation, but it's like, so is that troubadour, Bernard de Ventadorn, the same as the troubadour understood, written down 14th century, when it's no longer a musical phenomenon, when it's no longer, it might be the idea of an identity of a troubadour actually has a different purchase, a different historical meat to it than in the 12th century when it was a performative with an audience responding to it in a certain way. Do you see? So I've been like trying to think about that and dwell on that when you're asking this question, like, what is it? Because then it was a song, like a lyrics in a song. And then later on now there are lyrics and a text that are read. And then it might be, they might be constructed and attached to an author in this very, in a kind of way in a book. So I'm just like kind of thinking, not to get towards like the Virginia Jackson kind of thing at all, but like kind of in the way I see, kind of trying to compare where lyrics are and how they are and this concept of identity before you get to the pre-modern, all these debates about identity about a poem. There's also this like pretty much like, well, we don't really care about that as much. Like we all just agree upon that the conventions of this, the art of this love song. And then, you know what I mean? Like, so I don't know, Stephanie, if you have a response to that, but I'm thinking about that a lot.
Yeah, well, I mean, you wrote you this is the thing that you're a world authority on. There's the first practices can exist and be interesting and consistently identifiable across time before we have names for them. And I would argue that, and this is one of the things where I think Color is right, that the set of reading practices that we now take to constitute lyric seems to show up historically, and not only in the West, before the word lyric gets consistently used. Second, Marissa, you're talking about, I'm going to fork up his name because I don't speak French at all, Bernard de Ventadorn, that guy. The identities of authors. And I tried, and maybe I failed, to give an entire talk about poems, most of which have authors, and songs which definitely have songwriters and singers, without getting into what is an author, because I don't think the question of what do we do when we read a lyric poem needs to be connected in any determined or fixed or constant way to what is an author. Poems work as lyric, and songs work as songs. In ways that I would argue are similar or even identical, even for readers and listeners and performers whose sense of what is an author and what is the relation between a singer and a song are just miles apart. Some of the things that, I mean, I don't think we need to ask what an author is or what a poet is in order to have coherent and useful answers to the question of what lyric poems become over time, even though, like other medievalists who work on manuscript transmission, like Marissa is involved in answering both questions. They're both really cool questions, but I want to disarticulate them because you can answer one while putting the other in the fridge. Thank you.
I agree.
Oh, and we've got a question in the chat about how some identifiers are broader than others. Yeah, poetry is a much broader identifier than mad song. I mean, I'm not sure where else to go with that, but some labels describe proper subsets of the set of objects described by other labels. I'm not sure where to go with that.
Right. I mean, the way we would think about that is, you know, when you're specifying a category of objects, you're sort of saying what properties you want to pay attention to. Are you interested in sort of topological structure and notions of nearness? If so, are you also interested in angles and measurements and lengths? Are you interested in symmetry or just or not? And each of, you know, which things count as the same and which don't depends sort of very, very much on sort of what properties you're trying to highlight. So for instance, these spaces that I presented as being the same in certain categories of spaces would be very different in other categories of spaces. So if you're measuring your circle, then when you shrink it, it's a different circle.
I'm tempted to notice the way in which Taylor Swift is not James from the song Betty. They do not have the indiscernibility of identicals, but they're equivalent in certain respects. Oh, now we have to define politics. There are 12 open questions of the Q&A. There are 12 open questions of the Q&A. I think most of them are math specific. I'm going to try to go through them. One of them is actually a question for Franklin. Might chord substitution and a chord progression count as a 2-arrow in music? I'm going through the questions to see whether any of them are questions that I know how to answer. A lot of them come from the same person.
You can look to Emily.
I think I've answered all the ones I know how to answer. Jordan, Emily?
I mean, I'm looking to see if those ones I want to specifically direct to Emily.
I mean, we've discussed a few of them. So Zach's question about kind of functionalist theories of similarity, I'd say absolutely. You know, what counts as isomorphism or equivalence is entirely context dependent on what category you're in.
And I guess I would add, I mean, maybe it's worth saying that I think in mathematics, we tend to want to maintain that flexibility. It's not that there's sort of some right answer to which category 1 should work in. They're sort of different purposes demand of us different choices about what we consider the same. And, we really try to maintain that sort of, I guess maybe flexibility, suppleness is the word. I'm not quite sure what to call it, Emily, where we're not too locked in at any moment to sort of like one conceptual idea of what counts as the same, because for whatever purpose we're after, we might actually need to shift.
Well,
Is that fair to say?
I'd say sort of globally, we're not locked in the sense that, if one kind of category is not working for you, you could, redefine it and start over in a different one. But sort of locally, I'd say mathematicians are kind of locked in. I mean, we don't really treat things that have sort of as rich and complicated structure as like anything that actually exists in the real world, like much less a human being or something like that. Instead, we kind of abstract away and say, this is the list of axioms that define what this thing is. And this thing is, all we know about it are these axioms, and anything else you might imagine about it, any other intuitions you might have, we're not allowed to use them because they weren't on this list of axioms. And there's a flattening that I think happens in the process of taking a question that you might ask about in another discipline and making it into a mathematical question. We define all of our terms clearly. We want there to be one answer, yes or no, and we'd like everybody to agree. So that's an important difference.
I love this. Emily, I'm going to go through your slides again because I really want to get that 20% that I missed, which was exactly where you got to two functions, where I want to I'm going to ask for help and try to help myself, and I'm also looking. At least one person in the chat is saying that they want to draft new poems, and I really want to recommend, as someone who thinks about poetry and poetics in a way that tries to make the terms as clear as possible, and someone whose appears to be friendly to the way that mathematicians think, and who himself, if he hadn't met a particular professor at Cambridge on a particular day, probably would have gone into research math. I really can't recommend William Empson enough. And he's also great, like queer rep, if that's what you're looking for.
Hi, everyone. Thanks. I will teach.
Stephanie, I have a provocative question to end on. Do lyric poems have rights, or should they?
Define rights.
Well, I don't know. You raised the question in your thing, that a thing that may seem to have a person behind it, like an AI, you seemed pretty strongly to feel that such a thing should have rights. And then you said that sort of another such thing as a lyric poem.
I can answer that. The entity behind a lyric poem in their world, if we imagine them having taken further actions, you know what? I'm actually going to give an even simpler answer. Yes, a lyric poem has the right to be taken seriously as a representative of an imagined person, if indeed it succeeds at being lyric. But if it bores you and you can't project a person in it and you're like, who cares? Then it has not manifested its personhood, and it's like an AI that just flat out fails a Turing test.
Wow. Emily, does a type have the right to be taken seriously if and only if it has a term, what we might call a proof? Lightning round.
Yeah, I don't know. That you're displaying a strong bias for truth over falsehood. I don't know. So.
Okay. I'm a slave to my disciplinary conventions, as usual.
I mean, there is nothing outside the conventions.
But they're at least they're polite.
Well, sure. And I can't wait for them to resume in person. Although I'm pretty happy with this. It's a polite convention that you all exist and have spent time listening to us, and thank you. This is great. Everybody. Is there anything else that we should do? Romina, you're convening. Anything else we should be doing right now? Okay. I'm going to go drive some people home from work and school. Thank you to the everyone is here, and in particular the people I already know and admire, like Juliana and Franklin and Chris and Pelly, and I don't know who else is in here, but let's keep this going.
Thanks very much. Really appreciate it.
Bye, everybody.
Thank you. Bye. Bye, humans.
I'm gonna go eat the last quarter of an Italian beef